Hey everybody, welcome to Eureka Math / Engage New York Math, Module 1, Lesson 25, A Fraction as a Percent. I'm Mr. Quick. If you recall from our last lesson, we talked about percents. And we talked about percent as meaning per 100, per 100. So if I showed you this fraction, 1/100th, you know that can be written as 1%. You hopefully know that could also be written as 0.01 or 1/100th, and that could also be represented on a hundreds chart, just like this one, by filling in one box out of the 100 total. Your ratio would also then be 1 to 100 total, if you're going to do the part that was filled in to the total. So there's a lot of ways to look at percents. Again, fractions, ratios, decimals, actually the percent, a visual model. Today I'm going to show you some different ways to look at how to come to a percentage if the if the denominator is not already 100. Let's jump into it. Okay, here's our first example. In this picture, we have 3 cars and 2 trucks. So if we're going to look at that as a fraction or as a decimal, as a ratio, if we were going to say cars to trucks, we'd be looking at a 3:2 ratio. If we're going to say trucks to cars, we'd be looking at a 2:3 ratio. Either way you look at it, there are a total of 5 vehicles. If I were to say what percentage of all the vehicles are cars, well, we could write that as a fraction. We could say, well, we know there are 3 cars and there are 5 total, right? Because there's 3 cars and the 2 trucks. So 3/5 of the vehicles are cars. But wait a minute, I asked for the percentage. So what do? Well, we know that the percentage is per 100, right? So we want a number out of 100. And this is where that constant, or as I like to call it, I love to say it, the magic number comes in. 5 times what gives us 100? Well, I could look at 5 times 2 gives us 10, and then add another 0. Could do it that way. I could actually just do the division, 100 divided by 5. Or I could say, well, I know 5 times 10 is 50. Double that would be 100, so double the 10. Any way you slice it, you end up with 5 times 20. Gives you 100. Got to do the same thing, same constant to the numerator. 3 times 20, 3 times 2 is 6. Bring that 0 over. 60 out of 100, or 60% are cars. I'm going to show you a different way to look at that. If I do a tape diagram here, this is 1, 2, 3, 4, 5 parts that you can see here. Now, I would know, of course this is 0, there's 5 total vehicles, right? So that would be 1, that represents the first vehicle. 1, 2 would represent the first 2 vehicles, so on and so forth. So we'd have 1, 2, 3, 4. If I have up top, I know I'm going to try to get to 100%. So 100 divided by 5 parts, 100 divided by 5 would be 20. So I know I'm going to count by 20s, right? 0, 20, 40, 60, 80. I know there are 3 cars, so that means I'm looking for the 3 number. That would mean 60% are cars. If I said, well, how many are trucks? Well, there's 2 trucks. I look at 2, that would mean 40% are trucks. Another visual way, let's say I said, okay, 3/5 of all the vehicles shown are cars. What percentage is that? We could also look at it in terms of our hundreds chart. Now you might say, well, how are we going to figure out 3/5? Well, I'm going to show you. If we break this down into 1 part, 2 parts, 3 parts, 4 parts, and 5 parts, and then we filled in, and I'm doing this kind of sloppy, but I'm doing it partially for speed here. I filled in 3 of those parts. That would be 1, 2, 3, 4, 5, 6 columns. There's 10 per column. 60% equals 3/5 of 100. We can scale up or down, scale up, scale down, to find out a percentage. So let's say we have 8/10 of our classroom loves math. Hopefully it's 100%, but let's just say it's 8/10. And we want to find out what percentage that is. Well, we know we want to figure out how many out of 100 that would be, right? So here I'd use my constant or magic number. 10 times 10 would get me to 100. Do the same thing up top. 8 times 10 would give me 80. We've got 80 hundredths, or 80%. Or just for the fun of it, we could say 0.8 or 0.80 as my decimal. We can scale down because sometimes you might do something like, say, we surveyed 1,000 people. And of those 1,000 people, we know that 300 of them say that science is their favorite subject. So we want to know what that would be out of 100. Well, you can't multiply to go from 1,000 to 100. So you have to divide. So we would divide 1,000 divided by 10 gets me 100. 300 divided by 10. I know I can cancel out those 2 zeros, gives me 30, and I would know that is 30%, or if you want to look at it as a decimal, 0.3 or 0.30. What do you do if you have a fraction such as this one, 1/8? Well, there's not a whole number that I can use as a constant to multiply by 8 to get to 100, right? 8 times 12 would give us 96. 8 times 13 would give us 104. So there's not a number I can get there evenly. This is what you would do. You have 1/8, and you say, okay, I know that every fraction is a division problem, so this is 1 divided by 8, so I'm going to say 1 divided by 8. 8 goes into 1 0 times. 0 times 8 is 0. I subtract, I bring down the 1. I need to bring down a 0 here, which means I have to add a decimal. If I add a decimal here, I got to bring it up here. Pop that up there. 8 goes into 10 one time. 1 times 8 is 8. I subtract, I get 2. Bring down another 0. 8 goes into 20 2 times. 2 times 8 is 16. Subtract, I get a 4. I can bring down another 0. I can bring down as many zeros as I want after the decimal, right? Bring down that 0. 8 goes into 40 5 times. So if my decimal, which by the way would be 40, subtract, get 0, we're done. My decimal is 0.125. Well, when we had 0.25, we know that equaled 25%. This would be 12.5%. Okay, let's look at a couple of other quick examples. Renita claims that a score of 80% means that she answered 4/5 of the problems correctly. She drew the following picture to support her claim. So we can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 across times 1, 2, 3, 4, 5. She drew a hundreds chart. It doesn't look like your typical square hundreds chart, but it is still a hundreds chart. If each row is 20, she filled in 1, 2, 3, 4 of the rows out of 5, so she filled in 4/5 of the rows, and we know that we have 20, 40, 60, 80. That equals 80 out of 100. That does indeed equal 80%. So is she correct? Yes, she is. You could also just look up here and say, okay, well, it's 4/5. When we convert that to a percent, so out of 100, is this number here going to be 80? And in fact, 5 times 20 is 100. 4 times 20 is 80. It's a goofy looking 8. That's okay. So that does equal 80%. So she's correct. Here's another example where they've given you a diagram, much like the one we made on the last few slides there, the tape diagram. So you have up here 1 through 5. Down here you have 0% to 100%, and it looks like it counts by 20s, right? 20, 40, 60, 80, 100%. 80% is what fraction of the whole quantity? Well, if I look over here at 80%, it's 4 out of 5 total, right? 1, 2, 3, 4, and there's 5 total. So a fraction would be 4/5. 1/5 is what percent? Well, I'm going to go over here to 1 out of 5, right? 1/5. The 1 correlates with the 20%, so I end up with 20%. Finally, 50% is what fraction? Well, we don't have 50%. We have 40 and we have 60. 50 would be right smack dab in the middle. 40 is 2/5. 60 is 3/5. So what would be 50? Well, in between 2 and 3, you would have 2.5 out of 5, which correlates to 2.5 out of 5. Or you could say, multiply both of those by 10, 25 out of 50. Okay, we're running out of time. We will look at some more examples using fractions and how to convert in class. Thank you for watching, and hope you enjoyed it, and hope you're picking it up. We'll talk soon.